we get the following answers to the diamond problem. So check your work. You should get -3 and -4 for the first one. X and 5 plus x, because we can't combine those unlike terms. Multiply to -36, add to 0 is +6 and -6. Or you could have flip-flopped them if you wanted. Doesn't matter the order in which you write these. Let's see. Should get -8 and +3. -8 and -2. And what? +6 and -1. So, if we're factoring meaning breaking down something complex, something that's being added together, and breaking down into smaller, simpler things that are multiplied together. First decision we want to make is when we're looking at what we're asking to factor, is it are there 2 terms or are there 3? That's a matter of just counting. If you only see 2 terms, then there's really only 2 things that can be going on. They're either being added together or they're being subtracted. If you have 2 terms and they're being added together, you might as well just stop, because there's nothing more you can do. Not factorable. Okay? If you have 2 terms and they're being subtracted, however, now we might be in business. If we can write them as what's called the difference of 2 perfect squares, then we can factor them with a pattern and go really quick. Okay? So for example, 4x squared minus 49, those are 2 numbers that are what are called perfect squares. You can multiply something by itself to get each of these 2 numbers. For example, what times itself is 4x squared? 2x. Right? So in this case, our first perfect square, or I'll call it A, is say 2x. 2x times itself is 4x squared. Can we do the same trick with 49? Yeah, 7. Therefore, these are 2 perfect squares that are being subtracted. This factors in a nice pattern. And the pattern is this thing. Add them together and subtract them together. Or this should factor very quickly to 2x plus 7 and 2x minus 7. So you can check your work with chart multiplying. That works out fine. And we can go from there. However, what we're going to do now is, well, life gets more interesting and more complicated if we now have a 3-term polynomial or a trinomial. If you have a 3-term polynomial or a trinomial, factoring is a little bit, there's more to it. You've seen in the past, likely many of you have seen like guess and check. Like play the numbers game type method.
Wait, what? I thought we were doing guess and check.
Oh, no. Yeah, so if you were a guess and check person, like a lot of people use the guess and check method to factor. And that's fine, but that can take a while because you might not guess the right time to guess it correctly the first time. Some people learned the what's it called? The factor by grouping, like the split the middle term into 2 pieces and then factor what's in common and regroup that method. Does that sound like something you've seen before? The split the middle term into 2 pieces, like that method. That's a cool method. The method I'm going to show you is probably going to be brand new, but it's very similar to the split the middle term one. We're going to basically do that with through this little process here. We're going to make some diagrams that'll make life easier. Okay. So to get started, it's called the box and diamond method for a reason, because we're going to do 2 things. We're going to make a diamond and use a box to factor. Okay. First step, when we're trying to factor using this new method, is we're going to look at our trinomial and we're going to divide out any common factor. It's called the GCF. If there's nothing in common, we're going to do the following. We're going to create a diamond problem. In the adding box, In the adding box of our diamond problem, we're going to put the what's called the linear term or the middle term of our trinomial. So the bottom box of our diamond will put the linear term or the middle term of our polynomial we're trying to factor. In the multiply box, we'll multiply the outside terms. So the quadratic term, or the term with the x squared, and the constant term, the term with no variable. We'll multiply the outside terms. That'll look like this. So for example 1, first we'll create our little diamond problem. In the adding box, which is down below. In the adding box, so in the bottom goes the constant term, or the linear term, or the middle one. So the middle term of what I'm trying to factor is negative 6x. Okay, is the adding box of our diamond problem. In the multiply box, or the top box, goes multiply the two outside terms. So multiply x squared and negative 55. What does that give us? Okay, I have nothing crazy here. Step 3 is solve the diamond problem. Okay, solve the diamond problem, which most of you have already done. Negative 11x and 5x is multiply negative 55, add up to negative 6. 4, we're going to now use our box. So we're going to create a box diagram. And we'll create it in the following manner. So draw a 2x2 box. Draw a 2x2 box. In the upper right corner goes the first term of the thing we're trying to factor. In the upper left, the first box goes the first term of what we're trying to factor. Okay? The setup's going to take a little bit. It can take a little bit used to, but once you get it, it's going to go really quick. First box goes the first term. And the last box goes the last term of what we're trying to factor. In this case, negative 55. In these two missing boxes goes the answers to the diamond problem you just solved. In whatever order you want to put them, does not matter. With the answers to the diamond problems that you just solved. Okay. Okay. So what's in common in the rows? The first one is an x. How about between negative 11x and negative 55? What's in common? Negative 11 is in common between negative 11x and negative 55. Okay? We'll work the columns this time. What's in common between x squared and negative 11x? X. And what's in common between 5x and negative 55? 5. Your answer to the factoring problem is written above and to the side. Okay? So we'll factor out what's in common, or the GCF, of each row and column. How would you factor number 2? Oh, the first way, because there's only 2 terms, and it's 2 perfect squares being subtracted. Difference of 2 squares. So then what are our 2 things? What are the 2, what are like our A and our B? X, B is what, 6? So then you have x plus 6, x minus 6. Noticing that's a difference of 2 squares, we can make life quicker. We don't need to use this fancy tools. Okay. On your paper, I wrote negative 9x minus 14, please change it to a plus, otherwise we can't factor this. I'd like to give you some practice factor. You'll notice that you would be able to notice if it's not factorable, because you could set up a diamond problem, and if there's no way to answer the diamond problem, that's not factorable. Right? Let's make this thing factorable to get some practice. Okay? So change the last thing to a plus. And let's go like this. First step, is there anything in common? Not amongst all three. Since it's not amongst all three, there's nothing in common. Step 2, make a diamond. Add box goes the linear term and the middle term. The multiply box goes multiply the two outer terms. 14 times x is 14x squared. Solve the diamond problem. What are the answers, the solutions to this diamond problem?
Negative 7x and
Negative 7x, negative 2x. That's step 3. Step 4 is create yourself a box or a chart. Fill in the chart accordingly. First term goes in the first box, x squared. Last term goes in the last box, positive 14. In the missing boxes go the solutions to your diamond problem in whatever order you choose, doesn't matter. I'm going to go 7x, negative 7x, and negative 2x. You could flip-flop them, you get the same answer in the end. Step 5 says factor out the greatest common factor in each row, in each column. So let's find what's in common. In common between x squared and negative 2x. In common between x squared and negative 7x. X. Okay. This is an example of one that can actually get kind of messy. If you have a negative and then a positive, you got to be kind of careful here. What's in common between negative 7x and 14? 7. What's in common between negative 2x and x squared? Oh, excuse me, we already did that one, sorry. Negative 2x, we already did that one, why would we do that? Negative 2x and 14. Now here's the problem. If we just pull up positive 2 and positive 7, we should be able to go backwards and multiply and get this chart. So we should be able to say x times x is this box. Is that true? How about x times 7 is this box? No, what does it need to be? Okay. 2 times x should be this box. What do we need? Okay, now does adding those two negatives that change the last box? What's negative 2 times negative 7? Okay, so now it actually works. So our solutions would be x minus 7 times x minus 2. Last one, notice in the last one that there's a 3 in common amongst all three terms. So we'll divide that out. Or we'll write what's in common in front, and then divide each term by this thing in common. So if we divide out 3 from 3x squared, what's left? X squared. If you divide out 3 from 12x, what's left over? 4 x's. And if you divide out 3 from 15, what's left over? So we can rewrite this polynomial as 3 times this smaller one. And now you can factor the smaller one, or you could use the box and diamond to factor this smaller polynomial with x squared, 4x, and minus 5. And go from there. And come up with an answer or a solution that's completely factored.